Okay, in this video I'm going to show you how to use the Energy Plus section of the workflow to perform a thermal calculation with passive shading. I'm just going to start out by showing you the constructions, because if you saw the shared assumptions video, you will know that the input geometry is very simplified. That's because we define the geometry here. If we take a look at the facade construction as an example, we have the three layers of the material of the facade here. There is slate, insulation, and concrete. And then you define the thickness of each layer and the density and the specific heat and all these specifications. You add them to this EP construction component. You do that for all your different surfaces, and add them to this component up here, which will then add them to the project library. Now, to look at the passive shading, we're going to go to this box over here called passive shading. Here we have a component created at MicroShade, which allows us to import the BSDF files. It has to be an IDF format, and it's called LBNL window because that's where we've created the XML file, the IDF files that you find here. So you take the input over here in the BSDF file part of the shared assumptions. I'm going to use the MicroShade F in this tutorial. Just remember that it has to be IDF format when you're using Energy Plus. So I'm connecting that to the component here. This component adds all the materials to the library, same as for the constructions. And just set this toggle to true to add them. And the next thing we do is we take this BSDF construction name and add it to the window construction up here, like that. Sometimes when you open the workflow, these will turn orange and show an error message. Just disable them and re-enable them, and they should be fine. You do that by clicking Control E, Control E. Up here we have the different types of surfaces defined, as well as whether these three are adiabatic, and this is when the external wall is exposed to the outdoors. So that's what's defined up here. And we add all of this to one data point here, and then into this create honeybee zones component. Here you can also give your honeybee zone a name, which is useful if you have more zones than one. In this case, we're only using one zone. So that one is connected to this data point, which is honeybee zone without dynamic shades. This is useful because we can also do it with dynamic shades in the workflow, but we're not going to do that now, so I'm just going to leave it like this. And then you connect it to this component, which allows us to set these zone thresholds. I've just set for heating and cooling, but you can set it as however you want for your own projects. We take the honeybee zones output from this one into the honeybee zones input in this component, where you get to specify schedules for occupancy and lighting and equipment and whatnot. I've just set an 8 to 5 occupancy schedule for the weekdays, and then no one there on the weekend, so it's regular office hours. And then you take the honeybee zone output into the honeybee zone input in the next one, which allows us to set the zone loads. That's the infiltration and the internal loads like equipment and lighting and the amount of people giving off heat in the room. And now we're going to take the honeybee zones connected to a data point and then into this component, which is the run energy simulation component. This one has a variety of different required inputs, one of them being additional strings, you see here. That one comes from the component in passive shading down here, and you just make sure that that one is connected to additional strings. Up here we have the energy simulation parameters. You can use those if you want, or you can just leave them as we've defined them. And now we're ready to run the simulation. I'm going to do that by double-clicking this toggle to write the IDF file, to write the file, and this one to run it. And I'm going to pause the recording while I do that because it may take a while. Okay, now the simulation has run. You can see here that you get an orange error message saying that it failed to find certain components in the library. Don't worry too much about that. as long as the component still runs, you should be fine. And you can see that because if it hadn't run, it would have been completely red. And we also get results over here. So using this result file address component, you can see a list of all the outputs that we've calculated. You can get thermal loads and heating, cooling, electricity. I'm going to show an example using the operative temperature to calculate the amount of overheating, if there is any. According to the standard, you need to use the occupancy schedule. So we only count the hours that the office is actually in use. And I do that using this component. I create an 8 to 5 schedule, and then we only take the hours that are occupied using this component. We use call pattern, and then we call it again to find the temperatures that are above the threshold value that we set using the slider. So there's a limit saying you can have about 100 hours above 26 degrees in a year. So if we look at this, we have 24 over 26 degrees and none over 27. So we're well within the limit here. Up here I've shown an example of how you can calculate the cooling energy consumption per square meter if you're interested in that. So that was a quick run through of how you use the workflow to perform a thermal calculation with passive shading in Energy Plus.